Beneath the sunlit waters off Florida, a secret of immense scale has been hiding for millennia. Marine researchers, during routine deep-sea surveys, stumbled upon something extraordinary: a network of massive oceanic sinkholes plunging deep into the Earth's crust. What first appeared as sonar anomalies, perhaps collapsed reefs or odd rock formations, were actually colossal voids beneath a densely populated coastline. The initial sonar returns were so bizarre, they were almost dismissed as malfunctions, but as more data arrived, a chilling picture emerged. These were deep, vertical shafts some hundreds of feet deep. The implications were staggering, raising urgent questions about the region's geology and the safety of the coastline. Imagine the moment on that research vessel, the hum of equipment, the glow of screens, and the realization that the world beneath was far less stable than believed. These weren't just holes. They were dynamic systems, with powerful downward currents at their mouths, suggesting a direct connection between the ocean and vast subterranean spaces. The ocean, it seemed, was leaking into the Earth itself. This discovery challenged long-held assumptions and opened a Pandora's box of geological and ecological questions. And this wasn't in some remote corner of the world, it was right off the US coast, near cities, beaches, and shipping lanes. The proximity to human activity made the discovery all the more alarming. The sinkholes represent a previously unknown hazard, a reminder that our planet still holds terrifying secrets. The familiar blue expanse now masked a hidden underworld of immense power and potential danger. The age of exploration, it turns out, is far from over. Uncovering these subterranean giants required advanced technology and ingenuity. Sophisticated multi-beam sonar systems first revealed the sharp drop-offs and vertical walls, far deeper than expected. Ghostly echoes from the abyss alerted scientists that something was very wrong. Remotely operated vehicles, or ROVs, equipped with lights, cameras, and robotic arms, became the scientists' eyes in the deep. The footage confirmed the sonar data sheer dark shafts descending into bottomless pits. Navigating these currents was treacherous, threatening to pull the ROVs into the depths. The ROVs collected invaluable data, mapping the internal structure and revealing complex networks of side passages and hidden caverns. They also measured water temperature, salinity, and chemistry, searching for clues about the sinkhole's origins. This combination of sonar mapping and robotic exploration transformed abstract data into a tangible and unsettling reality. The true scale and complexity of these features had finally come to light. The discovery triggered an immediate response from the US government. Authorities swiftly shut down large portions of Florida's coastal waters, halting all civilian activity. The US Coast Guard and Navy enforced the perimeter, ensuring no unauthorized vessels entered the restricted zone. The Navy's involvement underscored the gravity of the situation. These voids posed risks to submarine operations and national security. Publicly, the shutdown was about navigational hazards and unpredictable currents. Privately, officials needed time to assess the threat without public panic. Experts raced to understand the stability of the seafloor and the potential for tsunamis or infrastructure damage. The closure disrupted Florida's economy, affecting tourism, fishing, and shipping. Fishing communities faced uncertainty, and shipping companies rerouted vessels, causing delays and higher costs. The public reacted with fear, frustration, and curiosity. The government's information blackout only fueled speculation about the true nature of the terror beneath the waves. The region's future suddenly seemed uncertain. The stakes had never been higher. The word sinkhole barely captures the scale of these oceanic chasms. Some are vast enough to swallow entire ships or skyscrapers, plunging over 1,500 feet into the earth. Sonar and ROVs revealed a labyrinthine system of caverns and tunnels stretching for miles beneath the seafloor. These are not isolated features, but an interconnected network, suggesting the Florida platform is far more hollow and fragile than imagined. The shafts are sheer and vertical, more like colossal wells than typical sinkholes. ROVs captured images of crumbling rock faces, showing these structures are still evolving. Chunks of rock tumble into the abyss, widening the mouths in real time. The instability is alarming. The seafloor is in a constant state of slow-motion collapse. Powerful downward currents at the mouths indicate a massive exchange of water with a subterranean aquifer. We are witnessing a dynamic, breathing geological system of terrifying proportions. Scientists are racing to explain these monstrous voids, and two main theories have emerged. One suggests they're relics from the last ice age, when acidic rainwater carved out vast caverns in exposed limestone, later drowned by rising seas. The other, more unsettling theory, is that groundwater in the Floridan aquifer is still actively dissolving the rock, making the sinkholes grow larger and more unstable. Powerful downward currents support the idea of an active, dynamic system. Regardless of origin, the risks are immense. A large-scale collapse could displace huge volumes of water, generating a tsunami with little warning. There's also concern about seismic activity. Collapse could trigger tremors in a region unprepared for earthquakes. Some geologists speculate these voids could be linked to deeper, unknown fault lines, challenging our understanding of tectonic safety. The ground beneath Florida's waves is now a source of profound geological uncertainty. These abyssal shafts are far from barren. They host unique, bizarre ecosystems. Glowing bacterial mats coat the walls, thriving on chemical reactions rather than sunlight. This chemosynthetic life, more common at hydrothermal vents, forms the base of a complex food web. Unusual fish and crustaceans gather around the rims, drawn by the altered chemistry. Each sinkhole could be an isolated island of evolution, harboring species found nowhere else. But the unique chemistry can harm nearby coral reefs already stressed by warming and acidification. A collapse could send sediment clouds drifting over reefs, blocking sunlight and suffocating corals. Astrobiologists are fascinated. These ecosystems may offer clues to life on other worlds, like Europa or Enceladus. Studying these deep, dark holes could help us search for life beyond Earth. The sinkholes threaten more than just the seafloor. They could impact Florida's freshwater supply. These voids may act as conduits, allowing saltwater to contaminate the Floridan aquifer, endangering drinking water for millions. There's also the risk of a massive methane release if the sinkholes destabilize frozen methane hydrates, accelerating global warming. The powerful suction at the mouths could disrupt local currents and even the Gulf Stream, altering climate patterns far beyond Florida. The constant discharge of chemically altered water can create dead zones on the sea floor, threatening marine life. Sediment clouds from collapses endanger fragile coral reefs, vital for fish nurseries and coastal protection. The destruction of reefs would have a domino effect on the entire marine food web. These sinkholes are not just geological curiosities, they're a ticking environmental time bomb. The consequences could be local and global. The discovery of Florida's oceanic sinkholes has shaken the region's economy and society. The shutdown of coastal waters crippled tourism and fishing, while property values and future development are now in question. National security is at stake. The altered seafloor poses risks and opportunities for submarine operations. The need to map and monitor this new underwater landscape is now a military priority. The challenge is driving rapid innovation. New, robust underwater vehicles and autonomous drones are being developed for exploration. These technological leaps will benefit all deep-sea research. Ultimately, the sinkholes remind us how little we know about our own planet, and how much remains to be explored and protected. The terror they inspire is matched only by the wonder, driving us to understand and safeguard our world.